Okay, so to find out what the value of that is, this logarithmic function has a base of x. When we write it as an exponential function, then the bases are the same. It'll be x to some power. And to get the order the other pieces are in, start with the base and cycle through. You'll get x to the power 2 equals 36. So that's asking what number squared is 36. Obviously it's 6, but you could also get it by solving that by taking the square root of both sides. And you'll get x equaling 6 that way as well. And some might be wondering, well, why isn't it plus and minus 6? Well, because the base cannot be negative. That's one of the restrictions we said were on the base, that it had to be, couldn't be 0, had to be greater than 0 and couldn't be 1. Okay, so again, we'll see why that's true as we get a little deeper into this chapter. Okay, this is me never minding right now, okay? Okay, question C. Again, we'll convert from logarithmic to exponential by starting with the base and cycling through. It'll be 64 to the 2/3 equals x. And we can evaluate this on our calculator, remembering that power 2/3 means the cube root of 64 squared. And it doesn't matter what order you do those in. You can take the cube root first, square second, or vice versa. If we do the cube root of 64 squared, it's 16. And I mean, you don't even have to do that conversion. If you do 64 to the power 2/3 in your calculator, it does it. It takes the cube root and squares it. But the cube root of 64 is 4, and 4 squared is 16. Okay? So for these ones, again, it says determine the value of x. So try A on your own, and then we'll check it. So start with the base and cycle through. You'll get 4 to the negative 2 equals x. 4 to the negative 2 is 1 over 4 to the positive 2. 1 over 4 squared. The answer is 1/16. Okay, try B on your own. So when you convert from logarithmic to exponential, Starting with the base and cycling through, you'll get 16 to the negative 1/4 equaling x, or x equaling 1 over 16 to the positive 1/4, and power 1/4 means the fourth root of 16, which is 2. So 1/2 is the answer to that. And then for C, start with the base and cycle through. X to the 2/3 equals 9. So to do this one, what I would do, I want to know what x to the 1 equals. And to get this power 2/3 become 1, I raise both sides to the power. That's the reciprocal of 2/3. The reciprocal of 2 over 3 is 3 over 2. And the reason this works is because now, when I multiply these exponents, I'll get x to the 6 over 6, which is 1. And 9 to the power 3/2, well, that's the square root of 9 cubed. The square root of 9 is 3, and 3 cubed is 27. So that's the value of that. Now, if you have a newer TI calculator, there is a log with different base function on the calculator. Just trying to remember where it is. Alpha F2, yeah. Alpha F2, and then number 5 in this list is log with a different base. So we found our answer here to be 27, which the x was in the base position. So it should be log base 27 of 9. That should equal 2/3, which is 0.6 repeating, and it does. So that's checking on our calculator that our answer of 27 is correct. So older operating systems don't have this. So if you have an older version of a TI calculator, it doesn't have this in there. But to check alpha window, and then number 5 in that list is log with a different base than 10. Okay, so using this, we could have gone back and checked some of these other ones as well. So for B, we found the answer to be 1/2. Log base 16 of 1/2 should equal negative 1/4. So if I go here and I go log base 16 of 1/2, or 0.5, that should equal negative 1/4, and it does. Question A, log base 4 of what number is negative 2? We found our answer to be 1/16. So log base 4 of 1/16 should equal negative 2, and it does. Okay, so what if you don't have this? Does anyone's calculator not have this function on it? Yours doesn't? Okay, so you can use what's known as the change of base identity, which we will be talking about fairly soon here. But what the change of base identity is, what this is, it says that if you have log base 4 of x, what that means, it means log x over log 4. The log of the argument divided by the log of the base. That's the change of base identity. So we'll be looking at that fairly soon here. But you can use it if you don't have a calculator that has that log changed base function in it. Because you see these logs, log x over log 4, there's no base indicated there. So that means they're common logs, base 10. So it allows you to evaluate logs that are a base other than base 10, like this one here. So again, we found our answer to be log x equaling 1/16. So for this question, if you use the change of base identity, log base 4 of 1/16 would equal the log of 1/16, the argument divided by the log of 4. And that should equal -2, because that's what this original statement says for question A. We found our answer for x to be 1/16. So if you use the change of base identity, again, this allows you just use the log key. The log of 1/16, you're going to close the bracket after that, divided by the log of 4. It does equal -2. So it works. But the change of base identity can be used to evaluate any log with any base by using that change of base identity, because it makes it so that the bases are log 10, or excuse me, base 10, which our calculator is programmed to evaluate. Okay, we're going to stop there for now. So you should work on these questions on page 380 to 381. And I will post these solutions to Google Classroom so that you can check your answers. Again, this practice is important. It'll help you get ready for any upcoming quizzes or tests. Okay? So those are the questions you should be working on.